In this video, we'll walk you through how Gigaman's resilient inline arrangement manages traffic in high availability environments using dual nodes. RIA routes traffic based on IP address parity, source IP for top interfaces, and destination IP for bottom. Even ending IPs are directed to one node, odd ending to the other, with internode forwarding handled via IBP as needed. Before we get started with Inline TLS SSL Decryption using RIA, let's quickly walk through the prerequisites. You'll need a two-node resilient setup with both devices already configured. Make sure you're using inline-capable ports, and where required, inline bypass modules for fail-open protection. Cable your inline nodes in path, that is, client to device and to server. Ensure both nodes use identical tool connectivity for consistent behavior. Your inline tools also need to match across both nodes so traffic distribution stays predictable. Next, confirm you're using a Gen 2 or Gen 3 GigaSMART card and that the GigaSMART engine port is configured. Have your private keys and certificates ready. You'll need them for authentication, trust validation, and traffic decryption. Make sure your TLS policy is set, for example, decrypt TLS 1.2 and 1.3 and drop older versions. You'll also need an interbroker pathway between the nodes. Use at least one, preferably two or more aggregated tool ports. And remember, only one RIA-enabled SSL application should be configured per node pair. In this video, we'll be working with two GigaVUE HC1 devices running GigaVUE OS 6.11, and we'll use GigaVUE-FM 6.11 to deploy the RIA-enabled Inline TLS SSL Decryption solution. The on-screen layout shows the device configurations we'll be using for this deployment, including the inline network pairs, inline tool pairs, and the tool ports that form the interbroker pathway between the two nodes. For the IB pathway, the tool ports on both devices must be identical to ensure proper synchronization and resilient failover. Start by creating the software constructs for the first node. Create the inline network. We recommend that you select the traffic path as to-inline tool. This ensures that decrypted traffic is forwarded directly to the inline tool, where it can be analyzed or used for enforcement actions. Next, create the inline tool that will receive the decrypted traffic. Select the appropriate ports and apply the changes. Next, configure interbroker pathway. Select the required tool ports. Enter the minimum number of tool ports that must be operational for the interbroker pathway status to be active. Now repeat the same set of configurations for the second node. For the IB pathway, the tool ports on both devices must be identical to ensure proper synchronization and resilient failover. Now let's create the inline SSL app on the first node. Enable RIA. Select the second node and the appropriate GigaSMART engine ports for both nodes. The SSL monitor mode must be inline. Add the private keys and certificates. The same keys will be pushed to both nodes. You'll now see the available deployment types: inbound, outbound, and hybrid. Inbound uses your server's private key to stop threats before they reach your applications. Outbound uses a trusted internal CA to inspect user traffic going to the web. Hybrid combines both server keys for inbound and assigning CA for outbound for complete traffic protection. In this video, let's choose the outbound deployment type as an example. Now select the private key that you have added as the primary key. Once all the details are in place, it's time to deploy your solution. Simply drag and drop the inline network, flex inline map, and configure the required rules for the flex inline map. You can configure rules to either pass or drop traffic. In this case, we are configuring the rule to pass the TCP traffic to the server. Enable the RIA menu and pair the IB pathway of both nodes. Now drag and drop the inline SSL app followed by the inline tools and deploy the solution. Once the solution is deployed, you can use the GigaSMART Inline TLS SSL dashboards to gain deeper insights into session performance, network capacity, traffic decryption, and compliance analysis.